All right, today in algebra we're doing 6.1, starting a new chapter about graphing lines. Some good stuff here. All right, so our objectives. First, we're going to graph linear equations. Okay, they're linear, so they're going to make a line on the coordinate plane using ordered pairs. And we're going to determine the x and y intercepts of a linear equation. So some fun stuff. And no real world application today because we're just getting started with a new chapter. So first up, linear functions or linear equations. Okay, form a straight line. That's the big thing. We're going to have a straight line. And they have two different forms. We can use function notation and have f of x equals 2x plus 7. Or we can use more equation of a format, y equals 2x plus 7. So it can be a linear function using f of x or the equation format using y. All right, so this first one, example 1, says to graph a set x of ordered pairs, x comma y, such that y equals x plus 5. All right, so first of all, we need to make that table. So we're going to have our x. We're going to use the equation x plus 5 in there. And then we're going to get out, put our ordered pairs here. And so we could put equals y. All right, the 5 ordered pairs says hint, make a table of points to help. Okay, those standard ones that we typically use are -2, -1, 0, 1, and 2. Again, you don't have to, but that's what we're going to use today. So if our x is -2, that's what we're going to put in our equation. So -2 plus 5 equals 3. So our ordered pair is going to be -2 from our x column and 3 from what we got for the y. That's where we're making our ordered pair here. The colors are all messed up. I have several variations, I guess, of red. All right, let's try the next one. So we got -1 plus 5 equals 4. So my ordered pair is -1, comma 4. 0, so 0 plus 5 equals 5. My ordered pair is 0, comma 5. We're going to use 1. So 1 plus 5 equals 6. My ordered pair is 1, comma 6. And we're using 2 for x. So 2 plus 5 equals 7. My ordered pair is 2, comma 7. All right, and then we graph those. So -2, 1, 2, 3. -1, 1, 2, 3, 4, 0, 5. Hopefully you see a pattern. 1, 6, and 2, 7. All right, so we graph those, and the next thing that's important is to connect them. Okay, you want to connect those points. It's a little harder to do up here. So connect them, put an arrow on the end. Connect them and put an arrow on the end because it just keeps going. The domain here is all real numbers, so we have to extend those lines always. All right, then we've got standard form of a linear equation is ax plus by equals c. You are going to want to remember this, plot it in your head, okay? Sleep with it on a radio that just keeps repeating, I don't know. In there, a should be positive. And if a, b, or c are fractions or decimals, you can multiply them to make them integers. Okay, you don't have to leave them as fractions or decimals, but always try to make a positive. It's not necessarily a rule. You might see it when somebody else writes it or in the book where it's not, but the goal is to make it positive when you're writing them. All right, so let's actually try some. So example 2 down here says write the function f of x equals -5/7 x plus 2 as a linear equation in standard form. So first off, step one, we want to write the function as an equation. That just means we're going to change the f of x to be y. So y equals -5/7 x plus 2. I know last chapter we just spent like learning function notation and things. Now we're going back to equations. It's totally fine. Step 2, balance the equation as needed to get in standard form. So we want that ax plus by equals c. Okay, so currently x is on the right side. We're going to have to move it to the left of the equal sign. So we're going to do the opposite. It's currently being subtracted. So we're going to add 5/7 x. We get to add that whole term to both sides. Okay, we don't want to split up x and y this time. We want to move the whole term. So we're going to have 5/7 x plus y equals 2. Okay. All right, well, we just said that a should be positive, and if it's a fraction or a decimal, we should multiply it. Well, we have a fraction, so let's go ahead and multiply it. So the denominator is 7, so let's multiply this whole thing, the whole equation, by 7. That way we'll cancel this, and we'll have 5x plus 7 times y is 7y equals 14, because 7 times 2 is 14. Right? So that is in perfect standard form. Because remember, we have ax plus by equals c is our standard form. So in this case, a is equal to, yes, 5. B is equal to positive 7. Okay, don't forget that. And C is equal to, excellent, 14. Okay, because we're just where they line up here. A is 5, B is 7, C is 14. Awesome. Okay, let's flip to the back. All right, we're going to do some graphing. Notice this note up here. It says 2 points determine a line, but find a third just to make sure. Okay, it's always good to find that third point. So we're going to graph x plus 3y equals 4. The first thing is to solve the equation for y. Okay, that means we want to get y by itself, or isolate y. So if we've got x plus 3y equals 4, we're going to subtract x from both sides. This is where your balancing skills, or your solving an equation skills, are going to get really good. Okay, so we always put the x first, so I'm going to put negative x plus 4. We need to get y by itself, so we're going to divide by 3. So each of those parts is going to divide by 3. So we have y equals, what I mean by that is we're going to do negative x divided by 3. So that's going to be negative 1 divided by 3, and then we can write the x beside it. Plus, then we need to do the 4 divided by 3. So plus 4 thirds. Not the best problem maybe to start with, but it's fine. We can do it. It might make more sense to have it as negative x divided by 3. So maybe let me rewrite that. That might have been too much of a leap for us. So let's make this negative x divided by 3. We can keep it like that. All right. So we have done step 1. We have solved the equation for x. Step 2 says make a table of ordered pairs using, wait, this time it says convenient values for x. Okay, so I'm going to move our equation, or the expression, up into here. So we're going to take a negative x and divide it by 3, and then we're going to add 4 thirds to it. Okay, so what would be convenient numbers to use for x? Because it says use convenient numbers. 0 is typically convenient. Okay, let's check that out. So we're going to have negative 0 divided by 3 plus 4 thirds. Okay, but 0 is always a good one to check. Well, 0 divided by 3 is just 0. So 0 plus 4 thirds is 4 thirds. So remember, I'm going to take my x value and my y value to write my ordered pair. So it's going to be 0, 4 thirds. So maybe not the most convenient number that we could have used. What if we did, 1. Would 1 be a convenient number? So we're going to have negative 1 divided by 3 plus 4/3. Well, hey, a negative 1/3 plus 4/3 equals 3/3, which is 1. That is very convenient because then our ordered pair, like we ended up with a whole number. So 1, 1 is our ordered pair here. Any thoughts on another convenient number? Maybe you said it, maybe you didn't. We're going to use 4. So we're going to have negative, our x is 4, so negative 4 divided by 3 plus 4/3. The reason it's convenient, right? Negative 4/3 plus 4/3 equals 0. So our ordered pair is going to be 4, 0. And those are hard. This is hard to pick convenient numbers. If you can get them, great. If you get wonky answers, that's okay too. You just graph it like you solve it and then graph it to the best of your ability. But if you can figure out convenient numbers so that you get nice answers, that's going to be great. If not, use the 0, 1, 2, -2, -1, 0, 1, 2. Okay. Step 3 is to graph. Okay, so let's graph these. So I'm going to do 1, 1, 4, 1, 2, 3, 4, 0, and 0, 4/3. So it's a little bit more than 1. It's about a third of the way up. Okay, and step 4 says connect the points. Okay, this should be a straight line because it's a linear equation. Also, no domain restriction, so we connect all the points. Okay, so connect them and draw an arrow on each end. Extend it out. Okay, yours should be much straighter. Okay, feel free to use a ruler to make your points or your lines. That'd be great. All right, next step, we're going to talk about intercepts. So I'm not going to move this down to show you the intercepts. We're going to talk about them. Intercepts are where the graph crosses an axis. Okay, so where the graph crosses the axis. All right, so in this one, it can cross, this graph crosses our y-axis right here at that 4/3. Okay, so the y-intercept, abbreviation is INT, equals 4/3. It's right there. The x-intercept is where it crosses the x-axis, so that's right here. So the x-intercept equals 4. Okay, and that's right there. That's what an intercept is. That's what that definition down below is saying. I thought it would be more helpful for you to actually see it. So the intercept is where it crosses or intersects an axis. Okay, crosses the axis. Okay, so let's move down to example 4. It says use the x and y intercepts to graph 2x plus y equals 6. All right, this is actually much simpler than it sounds like maybe, because you're going to use y equals 0 to solve for the x-intercept. So if I take this equation, 2x plus y equals 6, and I'm using y equals 0, I'm going to have 2x plus 0 equals 6. Well, then I'm solving for x. So I divide by 2, and x equals 3. Now, I can make this an ordered pair. My ordered pair is 3, 0. My x is 3, my 0 was, or my y was 0 that I plugged in. Okay. Now I'm going to use x equals 0 to solve for my y-intercept. So take the same equation, 2x plus y equals 6. This time I'm plugging in x equals 0. So I'm going to have 2 times 0 plus y equals 6. Well, 2 times 0 is just 0, right? This is 0 plus y equals 6. So y equals 6. Done. My ordered pair is then my x value is the 0 that I plugged in. My y value is the 6 that I solved for. And then you need to graph the line. I forgot to put in graph paper there, obviously, so we might have to draw a quick graph in there. So 1, 2, 3. Let me go. I need to go a little higher. 4, 5, 6, and 1, 2, 3. All right. So if I'm graphing 3, 0, 1, 2, 3. There's my x-intercept. 0, 6, 1, 2, 3, 4, 5, 6. There's my y-intercept, and then graph the line between them. All right, this one's a toughie. I can't quite get my body out of the light. Oh, I missed it. I'm sorry. Couldn't get my head out of the light to get a good graph. But there's the graph of my line. Sorry, I forgot to get that glued in there. My apologies. All right, perfect work. Then let's look at the last part of your notes. Example 5. Graph each equation, then determine whether it is a function. Okay, so we've got, first of all, a is y equals -2. Okay, so that's kind of weird. Y equals -2. Okay, here's the fun part about that. I'm going to show it to you, and it doesn't matter what number you put in here for x. If x is, well, if my board would work, decided to give up on me. My eraser's not working. There it goes. I think glitch is over. All right, so if we put in a -2 for x, y is -2. If we put in 3 for x, y is -2. If we put in 0 for x, y is -2. Oh my goodness, everywhere. So let's graph those points. -2, -2. 3, -2. 0, -2. And we connect them, right? We just get a horizontal line. Anytime you have y equals 2, y equals 7, y equals any number, you get a horizontal line. Okay, so a horizontal line. It's not impossible to have this equation, so don't get freaked out. Now, second question then. Then determine whether this is a function. Is this a function? Yes, absolutely, because why? It passes the vertical line test. Woohoo! Yes, this is a function. All right, now let's look at b, x equals 3. So wait, this time we have x equals 3. So if we put in 3, right, we have to put a 3 in each of these columns. What number do we have for y? It doesn't matter. We could have -2, we could have 0, we could have a +4. It does not matter. So let's graph this one. 3, -2, 3, 0, 3, 4. Okay, so we graph the points. Now connect them. Put your arrows on. This, what kind of line is this one? Okay, anytime you get an x equals equation, you're going to have a vertical line. Okay, because it's anywhere that x equals 3 is what you're graphing. So is this equation a function? Absolutely not, right? Absolutely no. So I should put not a function. Okay, because it fails the vertical line test, because it is a vertical line. All right, that's it for today. Hopefully a good start after your Chapter 6 test yesterday. And I will see you guys tomorrow. Have a great evening.